So in this video, we're going to talk about two special types of exponents. So two special exponents. Zero exponents and negative exponents. Okay, and to help us figure out both of them, we're going to first start with a number that we know. So for instance, we know that 2 to the second power, that's really the same as 2 times 2, which is 4. And if I think about 2 to the third power, that's 2 times 2 times 2, which is 8. And 2 to the fourth power is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. And we could keep going this way, right? 2 to the fifth, if I work that out, would end up being 32. So, something to notice is that on this side here, right, the powers are going down. And on this side here, the numbers, as I move from 32 down to 16, from 16 down to 4, from 16 down to 8, from 8 down to 4, what I'm doing is I'm dividing by 2 each time. So I could use this to continue my pattern, right? So if I take 1 away from the number, so 2 to the power 2, now I'm going to do 2 to the power 1, all I have to do is take 4 divided by 2. So 4 divided by 2, which would give me 2. If I want to figure out 2 to the 0, all I have to do is 2 divided by 2, which is 1. And if I want to figure out 2 to the negative 1, so I keep subtracting 1, I keep going down this way, all I have to do is do 1 divided by 2. Even 2 to the negative 2, that would be 1/2 divided by 2. And if we think of 2 as 2 over 1, and I go to figure this out, right, I'm dividing 2 fractions, so I'm going to keep the first fraction, change from division to multiplication, and flip the second fraction. So I end up with 1 over 4. And notice, remember, 4 is 2 squared, so this is really 1 over 2 squared. So there's a couple things to notice. One of the things to notice is that 2 to the 0 turned out to be 1. And that's not just a coincidence. That actually will always happen. So anytime that we have a number raised to the 0 power, it's always going to be equal to 1. Always. Totally a rule. Every single time. So, 3 to the 0, that's 1. Negative 4 to the 0, that's 1. 17 to the 0, that's 1. Negative 167 raised to 0 power, that's also 1. Anything to the 0 power is 1. The other thing to notice is that here, on these two, so if I have 2 to the negative 1, that really becomes 1 over 2. I can think of this as the positive 1. And 2 to the negative 2, so 2 to the negative 2, became 1 over 2 to the positive 2. So the way I like to think about negative exponents is to say, if I have a number to a negative, we'll call this a, that's going to be 1 over the number to the a. And the way I think about this is the negative exponents means I'm unhappy. I need to change sides. Right? So I don't like my position. I need to change where I am. I need to change sides. So let's go through a couple examples here to try some things. So example, simplify. Okay, so A, 7 to the 0. So 7 to the 0, it's to 0 power, it's just going to be 1. B, negative 2 to the 0. Again, everything's raised to 0 power, it's just going to be 1. If I happen to have something like this, negative 2 to the 0. Now notice the difference between this one and this one. Here the negative is inside the parentheses and it's all being raised to the 0 power. Here the negative is outside of the parentheses. So this is really the same as negative, and then this part here, this 2 to the 0, that part is becoming a 1. So the final answer here is negative 1. And the reason why that negative stays there is because this negative here, it was out in front and it wasn't part of the 0. Let's see. D. I could have negative 4 over x raised to the 0 power. That's still just going to be 1. We can even have really huge things, right? So 7x to the 200 all raised to the 0 power. That's also still going to be 1. So anything raised to the 0 power is 1, but if you have stuff out in front, like here, that's not going to be a 1. So I'll do one more here with the 0 power. So like if I had 4 times, say, 3x to the 0, oops, I know that's not where I want the 0. 3x all raised to the 0 power. So this part here is what's raised to the 0 power. So that part's a 1, but that 4 is not raised to 0, so it's going to stay there as a 4. In terms of negatives, right? So F, G. If I had x to the negative 6, so what that's saying is it's saying that the x here, it doesn't like its position and it wants to move to the other side. So the way it's going to move to the other side is I'm going to move it. It's right now, you can think of it like it's on the top of a fraction. And so we're going to move it to the bottom of the fraction. And then remember, I talked about this in a previous video, fractions have to have a top. You can't have a fraction that doesn't have a top. So since there's nothing left on the top here, it's going to be a 1. Let's try another one. So what about 7a to the negative 11? So again, this a is going to move, and so this is going to be, again, think of this as a fraction over 1, and so the 7, now notice the 7 doesn't have anything negative attached to it. This negative 11 is only attached to the a, it's not attached to the 7. So the 7 is going to stay on the top, and then the a to the negative 11th, it's going to move to the other side and become a to the 11th. Here's another one. C to the negative 2 over b to the negative 4. So in this one, both the c and the b are raised to negative powers. So that means I want to move to the other side. So c to the negative 2 would come down to the bottom as c squared, and b to the negative 4 would go to the top as b to the 4th. Let's try this one. P squared, p to the negative 7th, all over p squared cubed. So in this case, right, I could put this one, if I move that p to the negative 7th down to the other side, right, I'd be left with a p squared on top and a p squared cubed on the bottom, and then that p to negative 7 will move down to the bottom. And now I can work on simplifying this like I did other exponent things. So on the top, I still just have a p squared. But on the bottom, this first part here, right, that's the power rule, p squared cubed. So that's going to be p to the 6th. So p to the 6th, p to the 7th. I can use the product rule to put these together, right? So p to a power, I add them together. So this is going to be p squared over p to the 13th. And now if I look at this, remember we did this a couple of videos ago, but I have 2 p's on the top and 13 p's on the bottom. So where do I have more p's? On the bottom. How many more p's do I have? I have 11 of them. So p to the 11 on the bottom, and I just have a 1 on the top. Let's see. What about k? So 2x over 3 all to the negative 2 power. So remember from the last video, I need to distribute this negative 2 to each of these pieces. Right? So this is going to become 2 to the negative 2, x to the negative 2, all over 3 to the negative 2. And now we're going to make things move sides, right? So that 2 to the negative 2, it's not happy where it is, so it's going to come down here to the bottom as a 2 squared. The x to the negative 2, it's not happy, so it's going to move down here as x squared. The 3 to the negative 2, it's not super happy, so it's going to move up here as 3 squared. And now I can just simplify these numbers, right? So 3 squared is 9, 2 squared is 4, and then I have x squared. And let's see, let's try a couple more harder ones. Oops, so what letter was that? K. Let's try L here. So what about 5p to the negative 2, q to the 5th, times negative 2p to the 4th, q to the negative 1. Okay, so again, the first thing I'm going to do is I'm going to think of these as being over 1, so I can think of them as a fraction, so I can talk about things that need to move sides. So 5 does not have a negative exponent, so it's going to stay on the top. Same thing, q to the 5th power, not a negative exponent, so it's going to stay on the top. So the only thing that's going to move is this p to the negative 2. So 5q to the 5th over p squared times my second fraction here. Okay, this is a big thing that people do. This negative here, it's not an exponent. The only time things move is if the negative is up here in the exponent. If the negative is out in front, that does not mean that the 2 needs to move to the other side. Only when it's up in the top as an exponent. So that negative 2 is going to stay on the top of the fraction. The p to the 4th is going to stay on the top of the fraction. And the q to the negative 1 is going to move to the bottom of the fraction. So it's going to move as just q. I could write it as q to the 1st. I don't have to write that one. And so now if I simplify, if I kind of put the tops together, right? So I have a fraction. So remember, to multiply fractions, you're going to multiply across the top and then multiply across the bottom. So we would have, and I'm going to rearrange a little bit. I'm going to have 5 times negative 2, q to the 5th, p to the 4th, over p squared, and then I'm just going to write q. And then 5 times negative 2 is negative 10. So I have negative 10, q to the 5th, p to the 4th, divided by p squared q. Okay, and now I just need to look at the top and the bottom and see if there's anything in common, which there is. There's q's on both places and p's on both places. So I need to look and say, okay, where are there more q's? Oh, there's more q's in the top, right? There's 5 in the top, 1 in the bottom. So how many more q's do I have? Oh, I have 4 more q's. So we have negative 10, q to the 4th. And then if I do the same thing with the p, I have 4 p's on the top and 2 p's on the bottom. So where do I have more p's? Oh, I have more p's on the top. How many more do I have? I have 2 more. That leaves nothing left on the bottom, right? So remember, you can always think of it as over 1. And when you're over 1, you don't have to write that part, right? So I could write this as negative 10 q to the 4th p squared. So let's try one more. So 5c d to the negative 3 divided by 10 d to the 5th, all raised to the negative 3 power. Ugh, that looks ugly. But it's okay. We have all the tools to do it. So the first thing I'm going to do is I'm going to take this negative 3 and I'm going to distribute it into all of the pieces. So it's got to go to the 5, to the c, here to the d. It's also got to go here to the 10, and here to this d. So if I do that, we're going to get 5 to the negative 3, c to the negative 3, d. Now this time, negative 3 times negative 3 is actually a positive 9, divided by 10 to the negative 3, and then d to the negative 15. Okay, step 1 done. So it looks a little better, right? I got rid of the exponent that was out here. So now what I'm going to do is I'm going to look at this stuff and I am going to look for negative exponents. So this has a negative exponent, so it needs to move. This has a negative exponent, it needs to move. This has a negative exponent, it needs to move. This has a negative exponent, it needs to move. So the 5 to the negative 3 is going to come down on the bottom. The c to, but not as a negative. 5 cubed. The c to the negative 3 is going to come down on the bottom as a c cubed. D to the 9th is going to stay on the top. 10 to the negative 3 would move here to the top as a 10 cubed. And d to the negative 15 would also move to the top as a d to the 15th. So if I kind of rewrite stuff a little bit, I have 10 cubed d to the 9th, d to the 15th, divided by 5 cubed, c cubed. Okay, so if I work out 10 cubed, that's actually 1,000. 10 times 10 times 10. This here, the d to the 9th and the d to the 15th, right? Remember, I can add these two together. So 9 and 15 is 24. So this becomes d to the 24th, divided by 5 cubed is 125, and c cubed. And then actually 125 goes into 1,000. So 125 goes into 125 once, and it goes into 1,000 8 times. And you could put that into your calculator, 1,000 divided by 125 to get that. And so in the end, we end up with 8d to the 24th divided by c cubed.